In this video, I'd like to look at importing some data from a CSV in Wolfram Mathematica here. And there will be some issues of there are sort of headers, or there may be extra columns of data, and sort of how to sort of select out what exactly we want to, for the purposes of we want to plot and fit the data. And sort of those extra columns will, those extra rows or columns will wreak havoc on that job we want to do. So first, let's read in some data. This is some data about planets, so I'll call it planets. I'm going to import it. I have here the URL. Over here, Control V. Okay, so let's just straight in import it and then see what it looks like. So Shift Enter. So there is the data. And this data had a row of headers, planet, period, distance. And it also, it had a column that gave the name of the planet. So I would like to make an XY scatter, a list plot or XY scatter plot of the numerical data. And I have items in here which are not what I want, the names of the planets, the headers, and so on. Okay, and I have what this out one, what planets is a list of lists. So the curly bracket is a list. So and then I have a list of lists. So the first list in the list of lists is planet, period, distance, and then the subsequent lists, list 2, if you will, is Mercury, and then its period and its distance. So if I want in such a thing, if I want to select out, you use a double square bracket notation. If I say planets, or planet square bracket 1, double square bracket, that should pick out the first list, which is the names of the fields. And if I want, say, the period of Mercury, then I would say it's the second list and it's the second item. And there's 0.76, the period in some unit for the period of Mercury. Okay. So now I can go ahead and list plot. Let's try to make a list plot of this data and see a problem and then work on fixing it. So if I say list plot of this data, Shift Enter, I'm getting this weirdness. I want a plot of eventually I want period versus distance, but I'm just getting this weird stuff, and this is because of the because of these words here. This is one of the weirdnesses is the names of the planets. That's more of the issue right here. And then there's an additional issue of the headers. So now there's a standard way to get rid of the headers, but I want to hold off on that for a second. So let's show some ways. Let's just work with the data as it's come in and try to select out what we want as it is, and then later on maybe we'll try to read it in more directly in a format we want. Okay, so we can say planets square bracket, and then I can say that I want, there's a notation where I can say I want all the rows, but I want just columns 2 and 3. let's see what that looks like. So I'm saying I want, so there's a, there's a comma separated notation of rows and columns. So I'm saying I want all rows and then columns 2 and 3. Let's have a look, see if that works. So I have selected out the period and distance, and I have all of the rows. So I still have those headers. I want to plot period versus distance. So I'd like distance to be the first, to be what I'm going to call the X. So I can just in my within the curly brackets, the 2, 3, I can make it 3, 2, and I can reverse that order. And I'm going to make a list plot of that. So a list plot of planets with, for now, all the rows. And I'm going to reverse 3 and 2 and make sure I have enough square brackets here. That should be enough, I think. And now I screwed something up. All right, so planets, square brackets. Oh, I do not have enough square brackets. So I need planets in 5. I see that I need planet, square bracket, all, comma, then my curly brackets, then 2 close square brackets, and then I need additional square brackets of the list plot method. Okay, there we go. And we've made a plot, and if I can add to this a plot label. Of Kepler's third law or something like that. And if I want also axes label, and that is this XY pair of, let's just say distance and period, the X and the Y. I'm not being good in giving you the full units here, but okay. So there is, so I have selected out, gotten rid of the names of the planets because that was throwing off my list plot. I've reversed the order of the columns, got the order of data that I wanted, but I still have a problem. Because now I'd like to do a fit and to a power law. And this header there is going to throw me off. So let's demo that. So I'm going to say, I don't know, Kepfit, some name of the fit is going to be FindFit. And what did I have in here? Planets, square bracket, all, comma, 3, 2, close, and another square bracket for that's the data. Then I want to fit to a form of A times X raised to the N, where my fitting parameters are A and N, the coefficient in the power, and my variable is X. And this, I believe, is not going to work, thrown off by that period and distance. So, and it's just sort of throwing off. Is not a list of real numbers with dimensions. Okay, and the part of it that's not real numbers is these words in the beginning. So now I'd like to get rid of the all, and so then I can get rid of the first. It's going to work with the data as it is. And so I'm going to come in here and replace the all. Now I want, for the rows, I don't want a select rows, but I want all the rows except the first one. And okay, so I've included they're listed. The rows are 1 through 10. The names, the name, distance, and period. Those sort of headers, if you will, and then 9 planets, I'm including Pluto. And so that's 1 to 10, and I don't want 1. And there are no Wolfram Mathematica notation for this is a double semicolon. So I want 2 to 10. So I want the data from 2 to 10, which is the numerical stuff. I want the columns 3 and 2, the distance and then the period, and then I want it fit. So let's see if this works. And it does indeed work. Okay, so now I have, now that I have no words, no strings in there, and so I have a select number of rows using the double semicolon notation. I have select columns using the curly brackets. I can control the order of the columns I'm selecting. And I have managed to fit. And then we can just, if we want, I'm just going to plot, just write my function 1.73655 times x raised to the 1.49804, and plot that from x from 0 up to, what am I going up to? It looks like 60. And let's shift enter that. And then there is a plot of the fit. And then I'm going to use just out to throw them together. So out and add, not out. Out comes eventually show. Show out. And where was my out 8? I'd like out 8 along with out, what was it, 11. And then I think I would like to display the equation. So I'm going to add an epilogue and use inset. And I'm going to say hold form to make it look, to make my power look a little nicer. And I'll say y equals 1.73655. And I don't want the star here, but I do want the asterisk. The caret, sorry, 9804. And then after hold form, I'm going to say that I want it where? I want it at an x of, I'll say 20 and a y of 600. And that's the match of hold form. That's the match of inset. I need to close off show. And let's try that. Okay, so there I have what I want. I have a title, I have axis labels, I have distance on the x-axis, which was what I wanted. Okay, so I read in the data just using simple import, and then I learned how to select out the things I don't want. So I didn't want in my plot, because it was throwing off my plot, any words, so I didn't want that first column. So that was here, that was this 3, 2. I didn't want that very first row. Also, it didn't throw off the ListPlot, but it threw off the FindFit. And so that I used this notation here to get a sequence of rows. And so that got me what I want. But now let's just go back and look at reading in, some variations on reading in. So I can read, because it's very standard for the first row to contain headers, sometimes multiple rows. I'm going to call this planets 2, and I'm going to use import. And get my URL again. And then there is a built-in thing, header lines. And this tells you that I don't want in my list, in what I read in, make a list, I don't want to include that first row is of headers, and I don't want it. So I'm going to shift enter. So that eliminated the problem with the headers. Now, the problem with not having the headers now is I don't necessarily know what the headers are. So I can play another game of what I call it, fields. And I want to bring in separately that first Control V. So now I want to bring in just the first row. So I'm going to use this this argument that's going to be sort of a triple. I'm just going to say data. And then I'm going to say rows and then columns. So now I'm saying here that I want only the first row and all the columns. And so that's going to bring in this little list of the field names. So now I know that then it's planet, period, distance. So now I know, especially with the numerical data, that the period is coming in first and the distance second. So that is header lines. That's a way to get rid of, a standard way, an easy way to get rid of the first line. But we can also play other games here and to say planets, I'll call it 3, I guess, import. And I can play other ways of reading in. So I read in one row, I can read in selected rows like I did before. And let's try to read in, if I want to read in all columns, let's do that for now. And shift enter. So that brought in all of my rows. In this case, I explicitly knew how many rows there were. And it brought in all the columns. Let's try planets 4, and just to show we can do a number of variations on this game of selecting out what we want. So I want the data. Let's say I want to end, let's say I want 3, 2. Okay, so now I'm trying to, as I read it in, and I could have done, let's do this in a smarter way. Let's say I want all the data. Let's see if this works, but there are header lines. So there's one header line, so let's try to ignore that and then read in all of the other rows. So then we don't need to know how many rows there are. And let's try to read in columns 2 and 3, but reverse their order. Can we do all that as we're reading in the data? Looks good. And then we should be able to go with that straight into a list plot of, what did I call it? Planets 4. And that it would be sort of curving, like if I'd plot it, if I didn't manage to exchange the X and Y, the power would be closer to 2/3 and would be sort of turning over. But this is a power greater than 1. So we know we managed to get the order reversed. Okay, and I think that's what I wanted to show. Either read in all the data and select things out using various notations to sort of select out to get rid of certain rows or to get rid of certain columns and maybe reorder things. And we saw that the headers in it and the extra column of planet names really threw off our graph. So that was terrible. It didn't throw off the initial list plot, but it did ruin the FindFit. And so then we needed to get rid of that first row to get FindFit to work. And then everything worked, and then at the end, we discovered that we could sort of use some arguments in import to sort of bring in the first place just what we wanted. So if there were a large data set, you can control and bring into Mathematica, Wolfram Cloud in this case, just the things you want. Okay, I think that's what I wanted to show you. Thanks very much for your attention.